Hi guys, in this video we are going to discuss about the important PYQs from the chapter Equilibrium. Equilibrium is a very important chapter for the NEET exam point of view since they asked in 2024 they asked 3 questions from this chapter guys, 3 questions. And in 2023 they asked 1 question, in 2022 they asked 2 questions again. So especially in last year they asked 3 questions, so of course in 2025 also, we are expecting a more number of questions from this chapter. So, it is the time to check which all are the questions, which all are the area they already covered in the previous year exams. Are you ready? Let's see. So, dears, this is the first question for the reaction. This is in 2024, okay? So, for the reaction, 2A reversibly gives B plus C, Kc equal to 4 into 10 raised to minus 3. Kc they given. Kc is the equilibrium constant they given. At a given time, the composition of reaction mixture is concentration of A, concentration of B, concentration of C are equal 2 into 10 raised to minus 3. So at any time, at some time, we don't know whether it is equilibrium or not. So at any time, we can find out what? Equilibrium quotient we can find out. Qc we can find out. What is Qc? Qc equal to concentration of B into concentration of C divided by concentration of A whole square. At any time we are calculating this value, that is what is called Qc. At equilibrium if we are calculating, that is what is called Kc, equilibrium constant. So concentration of B is how much? 2 into 10 raised to minus 3, and C is how much? C also 2 into 10 raised to minus 3, and what is A? A is 2 into 10 raised to minus 3 whole square. So everything will get cancelled, we will get 1. Now we can look the question, which of the following is correct? Reaction is at equilibrium, it is not at equilibrium. Kc equal to Qc, then it's called equilibrium. Here the thing is that this Qc value is 1, Kc value is 4 into 10 raised to minus 3. Meaning Qc value is greater than Kc. Qc value greater than Kc means what? That backward reaction will favor. Qc reaction less than Kc means what? Forward reaction will favor. So Qc reaction greater than Kc means what? Backward reaction favors. Reaction has a tendency to go in backward direction. Option 3 is the correct answer. You got the idea guys? Clear? Yes, that's it. Only one thing we have to remember, Qc equal to Kc, that is called equilibrium. At any time. At any time if you are calculating, that is Qc. Okay, then Qc greater than Kc, backward reaction will favor. Qc less than Kc, Qc is less than Kc, forward reaction will favor. Every time they will try to attain to equilibrium. That's the idea. Clear? Okay. We can move to the next question, dears. This is the next question. Second question. In which of the following equilibrium Kp and Kc are not equal? This also from question NEET 2024. See, second question. Kp and Kc are not equal. We know the idea, we know the relation between Kp and Kc. Kp equal to Kc into RT raised to delta Ng. This idea we know guys. Kc is the equilibrium constant in terms of concentration. R is the universal gas constant and T is the temperature in Kelvin scale. Delta Ng is the difference between number of gaseous molecules of product to that of reactant. Here, which thing will decide this Kp-Kc relation? This delta Ng. So delta Ng, we know the idea. If delta Ng equal to 0, if delta Ng equal to 0, then RT raised to 0, and number raised to 0 is 1. So Kp equal to Kc will come. Kp equal to Kc will come. So if delta Ng equal to 0, Kp equal to Kc. If delta Ng not equal to 0, Kp not equal to Kc. That's the idea. So whenever we are looking on the first one, they are asking not equal, not equal. What about the first one? Here in left hand side 1 gas, in right hand side 2 gas. So in the case of first one, delta Ng equal to 2 minus 1, 1. Delta Ng not 0. So that is our answer. In that case, Kp and Kc are not equal. What about the second case? Here 2 gas in the product side, 1 gas here, 1 gas here. So 2 gas in the reactant side. So 2 minus 2, 0 will come. That's our answer. And here also, that's our Kp equal to Kc. That's our required one. They're asking not Kp equal to Kc. So answer is option 1. Okay. So what about option 3? CO plus H2O. Here both are gases. Here both are gases. So 2 minus 2. And here you can see 2 minus 2. There also, so our answer is what? Option 1. Clear, dears? Let's look about the third question. That's actually a little bit mathematical one, but it's easy. Concepts are easy. So see, this is the question they given. Consider the following reaction in a sealed vessel at equilibrium with concentrations N2. N2 concentration they given at equilibrium. O2 concentration they given at equilibrium. NO concentration they given at equilibrium. So I can find out from that, I can find out Kc directly. Kc. What is Kc? Concentration of N2 into concentration of O2 divided by what? Concentration of NO whole square. NO whole square. This is the Kc value. So N2 value how much? N2 concentration of N2 equal to 3 into 10 raised to minus 3. Okay. Into O2 is equal to how much? O2 equal to 4.2 into 10 raised to minus 3. Okay. Divided by NO means how much? 2.8 into 10 raised to minus 3 whole square. 2.8 into 10 raised to minus 3 whole square. 10 raised to minus 3 square, 10 raised to minus 3 square we can get cancelled. So remaining will be 3 into 4.2 divided by 2.8 into 2.8. Once we are solving this one, we will get the answer 1.607 we will get. How much we will get? 1.607 we will get. Approximately we will get 1.607. Now again, they are telling that this reactions, we are starting with the 0.1 mole per liter. That's the initial concentration taken in a closed vessel. What will be the degree of dissociation of NO at equilibrium? How we will do it, dears? So we can start the same reaction. 2NO gas. Okay, 2NO gas, that is reacting to give you what? N2 plus O2. N2 plus O2. N2 gas plus O2 gas. So they given initial concentration. Initial concentration, they given 0.01 mole per liter. That time there is no nitrogen, there is no oxygen. We are telling let alpha be the degree of dissociation. Then at equilibrium, see, at equilibrium 0.01. That's the initial minus 0.01 alpha. Alpha percentage of 0.01 will be reacted. So initial minus that reacted. So that will be the remaining. If 2NO reacting, 1N2 is forming. From here 0.01 alpha and NO is reacting. Meaning it's half. 0.01 by 2 means 0.05 alpha will be forming. N2 will be forming. Same amount of O2 also will be forming. 0.05 alpha, since here 2NO if you are taking 1 mole of N2, 1 mole of O2 will form. From this one also we can write the Kc equation. What's the Kc equation? Equilibrium constant Kc equal to concentration of N2, that is 0.05 alpha, into concentration of O2, that also 0.05 alpha, divided by concentration of NO whole square, that means 0.01 minus 0.01 alpha whole square, that's equal to 0.05 alpha into 0.05 alpha divided by, from here I can take 1.01 out. So square is there, so 0.01 square into 1 minus alpha square. This is equal to how much they given? They already we find out what? That is equal to how much? 1.607. Equilibrium constant does not depend on initial concentration. So its value is 1.607. So once we are solving this one, we will get what? Alpha by 1 minus alpha. Alpha by 1 minus alpha equal to 2.54. Okay, 2.54. Alpha by 1 minus alpha equal to 2.54. So alpha equal to 1 minus alpha into 2.54. So that means 2.54 minus 2.54 alpha. I can write alpha equal to 1 minus, see, 1 minus alpha into 2.1 minus alpha into 2.54. That means 2.54 minus 2.54 alpha, that I am taking to here. So that will be 3.54 alpha equal to 2.54. Alpha equal to 2.54 by 3.54. That will be equal to 0.717 will come. 0.717 will come. Let's look about the option. Is there any option? Yes, option 4 is the correct answer. Clear, dears? It may take some time. So that kind of long type questions also will be there. That type of questions you can answer only last. After going through the whole easy question, then you can go with that one. Okay? Yeah. Anyhow, you got the idea? Yeah, that's it. Okay. Next again, we can move to the next question, dears. That's actually asked in 2023. 2K23. Okay, see, here the question is somewhat easier question. They asked delta G and equilibrium constant relation. What they are telling, the equilibrium concentration of the species in the reactions A plus B reversibly gives C plus D. Or, that means respectively they given concentration of A is 2, concentration of B is 3, concentration of C is 10, concentration of D is 6. Then they are asking delta G0 for the reaction. What's the equation for delta G0, DS? Delta G0 equal to minus 2.303 minus 2.303 RT logarithm of equilibrium constant. Okay, equilibrium constant. I will take Kc. So to find out R value, they given 2 calorie per mole per Kelvin. Okay, and temperature they given 300 Kelvin. We have to find out Kc. How I can find out Kc for the reaction? Concentration of C into concentration of D divided by concentration of A into concentration of B. So I can put the values. What about the concentration of C? Concentration of A and B are 2 and 3. C and D are 10 and 6. So I can write 10 into 6 divided by A and B. So 2 into 3. So 10 into 6, 60 divided by 6, meaning 10 will come. 10. So I can substitute the values. DS. Minus 2.303. R value they given in terms of calorie. All answers are in calorie. So 2 calorie, approximately 2 calorie, they given 2. Okay, temperature is 300. So 300 into log 10. What is log 10? Log 10 is 1. That we can eliminate. So remaining is 2.303 into 300. Okay. Minus 2.303 into 2 means minus 4.606 into 300 will come. Into how much will come? 300. So I am multiplying 4606 into 3. I am going to multiply. Okay, that I am going to multiply. Once I am multiplying, you can see 3 into 6 are 18. Then 1, 0, 1, 3, 3, 6 are 18. Then 1, 3, 4, 12, 13 will come and 2 zeros will be there. So 1, 2, 3. 1, 2, 3. So meaning minus 1381.8. Minus 1381.8. This much calorie. Is there any option like that? Yes, option 3. And here itself we can see that range only coming for this one and minus answers. 3, 4, 2. Only 3 answers are minus. Delta G always negative for these reactions. Okay, delta G equation is delta G0 equal to minus 2.03 RT log Kc. Is it okay? Yeah. So that's the idea. That's the idea for delta G0. Next again, we can go to the next question. This is the next question, dears. This is actually asked in 2022. So here, the pH of the solution containing 50 ml each of 0.10 molar sodium acetate and 0.01 molar acetic acid. Whenever we are seeing that sodium acetate, okay, sodium acetate, that is CH3COONA and CH3COOH. Once we see this one, that time itself, it's a mixture. That time itself, we must have to remember it is nothing but it is a buffer solution. What solution? It's a buffer solution. What kind of buffer? See, this actually salt of weak acid. And it is weak acid. Weak acid and salt of weak acid, they will give a buffer solution, that is acidic buffer. Acidic buffer. So what's the equation for acidic buffer? Acidic buffer pH. pH equal to pKa plus logarithm of concentration of salt divided by concentration of acid. That means that weak acid. pKa value they given. pKa value of that weak acid is 4.57. That they given 4.57 plus logarithm of concentration of salt. Salt is how much? 0.1 molar sodium acetate. So 0.1 divided by. So if you are taking that itself, that molarity itself, again we have to divide with the volume, but no need both equal volume we are taking. That time both will be getting cancelled. Okay, I am taking directly 0.1 and what? So acetic acid. Acetic acid, how much I am taking? 0.01, but volumes are same. I can directly write the value. That's equal to 4.57 plus log 0.1 by 0.01. That is log 10 will come. So 4.57 plus 1, that is 5.57. That's the answer. So answer is option 4 will be the answer, 5.57. So you have to remember this one. This equation is called Henderson-Hasselbalch equation. For basic buffer, we learned OH equal to pKb plus log salt by base, weak base. That also we learned, that you have to remember in mind. Okay, that you have to keep it in mind. Next question number, again, this is in 2022. Again, the second question, here is a mathematical one. It's a mathematical one, but easy one. Here also mathematical one. See, here 302. The previous one also mathematical. This also mathematical. Okay, so the ideas are, see, here it is actually asked from what? That chemical equilibrium they asked. The previous one pH related. That's ionic equilibrium they asked. So continuously that areas are coming. Okay, so you must have to focus about that. See, here this is the question. 3O2 reversibly gives 2O3. One equation they given. For the above reaction at 298 Kelvin, Kc they given. Kc value they given. Then if the concentration of O2 at equilibrium also they given, then they are asking concentration of O3 how much at equilibrium. Directly we can write the Kc value. Kc equal to, what's the equation? What's the equation? Law of equilibrium. So concentration of O3 whole square divided by what? Concentration of O2 whole cube. O2 whole cube. Am I correct? Yes. So we have to find out concentration of O3. I will keep that concentration of O3 whole square here. Kc into concentration of O2 cube I will write. So Kc value how much? That they given in the question. 3 into 10 raised to minus 59. So 3 into 10 raised to minus 59 into concentration of O2 how much? At equilibrium they given 0.04. 0.04 means 4 into 10 raised to minus 2. So 4 into 10 raised to minus 2 all raised to 3. Now ideas are simple. 3 into 10 raised to minus 59 into 4 cube means 4 into 4 into 4. So 16 into 4, 64. 64 into 10 raised to minus 6 will come. How much will come? 10 raised to minus 6 will come. So 3 into 64. 64 into 3. 3 4s are 12. 1, 3, 6, 18. 192. 192 into 192 into 10 raised to minus 59, 10 raised to minus 6, 10 raised to minus 65. This one I can write that O3 square. Concentration of O3 square equal to, I can write like that, 19.2 into 10 raised to minus 64. Then what is O3? Concentration of O3 equal to square root of 19.2 into 10 raised to minus 64. So 10 raised to minus 64 square root is 10 raised to minus 32. And square root of 19.2, we know square root of 16 is 4. Okay, 16 is 4. Square root of 25 is 5. So the answer is in between 4 and 5. We can check the option itself. 10 raised to minus 32. Here 10 raised to minus 63. 31. That is 31. This is minus 32. Yes, that will be the answer. 4.38 into 10 raised to minus 32. Option 4 is the correct answer. Okay, dears? Yeah. That's it. Clear? Yes. We can move to the next question. This is a question they asked in 2021. Here also they asked the pH related question. Let's look. Okay. So see, pKb of dimethylamine. Whenever they are telling pKb, that will be the weak base. Weak base. So pKb of dimethylamine. Dimethylamine. This is dimethylamine. Its pKb they given. Its pKb they given. Okay. pKb equal to how much? 3.27. And pKa of acetic acid. Acetic acid is a weak acid, or else pKa they given means weak acid. CH3COOH they given. pKa they given what? pKa equal to 4.77. Now they are asking what? It's a question. Respectively, the correct option of the pH of dimethyl ammonium acetate. How this dimethyl ammonium acetate is going to form? This one, they will lose one H plus. That H plus will be gained by this one. That only dimethyl. Okay, CH3 twice. Ammonium. Ammonium means NH2, that become NH3 plus, and along with that CH3COO minus acetate group will be there. So that's actually a salt. This weak base, weak acid, they are forming a salt. That salt pH only they are asking. Salt of weak acid, weak base. What's the formula? That's an example of simple buffer also. What's the formula? pH of weak acid and weak base, pH formula is what? pH equal to 7 plus half into pKa minus pKb salt hydrolysis, we discussed these ideas. So 7 plus half into pKa minus pKb. So that's equal to 7 plus half into pKa. How much? pKa they given 4.77. 4.77 minus 3.27. So that's equal to 7 plus half into, this is 1.5. 1.5 by 2 means 0.75. So 7 plus 0.75, that is 7.75. Option 3 is the correct answer. Clear, dears? Here also they asked the question. Salt hydrolysis pH calculation in 2021. So let's go to the next question. Be careful, okay? Next question, that is question in 2020. What's the question? Hydrolysis of sucrose is given by the following reaction. Sucrose plus H2O reversibly gives glucose plus fructose. Okay, that reaction we know, inversion of cane sugar. If the equilibrium constant Kc value they given 2 into 10 raised to 13 at 300 Kelvin, the value of delta G. This one we already learned, already in 2022 we already did. Delta G, 2023, delta G equal to what's the formula? Minus 2.303 nRT log Kc. This is the equation. But here there is no 2.303, they given ln. So we can 2.303 into log, we can write like that, minus RT ln Kc. Minus RT natural logarithm of Kc. So minus of R value they given 8.314 joule. Okay, 8.314 joule, Kelvin inverse, mole inverse into temperature. How much they given? Temperature they given 300. So 300 into 300 Kelvin into ln of Kc equal to 2 into 10 raised to 13. 2 into 10 raised to 13. No need to calculate. From the option itself they given in this order. So minus only one option is there. Only one option is there. Minus 8.314 joule, mole inverse, Kelvin inverse, then 300 Kelvin, then ln 2 into 10 raised to 13. Option 4 is the correct answer. Clear, dears? Yeah, that's it. Okay. Next, again it was an easy one. Next one in question in 2020. 2020, okay. The previous one we did actually 2020. Before that we did 2021. So again in 2020, one more question is there, dears. One more question is there. This is the question. Find out the solubility of NiOH twice in 0.1 molar NaOH. This is actually NCERT question. NCERT in text question is this one. Same question they asked here. So what's the idea? They are solubility of NiOH twice in NaOH. So how this NiOH twice will dissociate? NiOH twice will dissociate like Ni2 plus 2OH minus. Let the solubility of NiOH twice is S. Solubility of Ni2, then solubility of Ni2 plus will be S, then it will be 2S. This idea we know. But we are going to dissolve this one not in water, in NaOH. In NaOH we are dissolving. NaOH is a strong base that will completely dissociate. It will give Na plus and OH minus. Okay, here if I am taking 0.1 molar means 0.1 molar OH minus will be there. Common ion is OH minus. So the thing is that whenever common ion is there means solubility will decrease. So how I can calculate the ionic product? They are asking about ionic product they given. Okay, given that ionic product they given, they are asking about the solubility. Ionic product is nothing. That's actually their KSP value they are asking. KSP value they given. So I know that ionic product, K ionic product equal to, listen to me, K ionic product is equal to, it's not salt, that's why not KSP. Okay, so K ionic product is equal to, I can write concentration of Ni2 plus into concentration of OH minus all square. What's the concentration of Ni2 plus? Concentration of Ni2 plus is S. What's the concentration of OH minus? OH minus from this NiOH twice as well as OH minus from NaOH. So I can write 2S from this NiOH twice as well as we are getting OH minus from NaOH to 2S plus 0.1 all square. This ionic product value they given 2 into 10 raised to minus 15. 2 into 10 raised to minus 15. Now here is the concept you have to apply. This S value is very much less than, very much smaller value, very much smaller than 10 raised to minus 3. That's a very much smaller value, very smaller value. The solubility value is very much smaller. We learned that's actually the sparingly soluble salt, they are actually very smaller value, very smaller value. So this 2S plus 0.1 will be approximately equal to 2s plus 0.1 approximately equal to, I can write 0.1 itself. I can write 0.1 itself. So that become what? That become 2 into 10 raised to minus 15 is equal to, okay, 2 into 10 raised to minus 15 is equal to, I can write s into 0.1 all square. So only the thing you have to remember, whenever they are asking about a sparingly soluble salt, okay, less soluble thing in a common ion means that common ion concentration is enough. Whatever the strong acid or strong base, whatever they are giving, that common things, its concentration is enough, we have to use. Here this 0.1, that 0.1 only we have to use. No need of that particular common ion from concentration from where? That salt or whatever they given. Okay, so that is not required, not necessary. So s into 0.1 square. So what is s? Solubility 2 into 10 raised to minus 15 divided by 0.1 all square means 10 raised to minus 1 all square. So that's equal to 2 into 10 raised to minus 15 divided by 10 raised to minus 2. That's equal to 2 into 10 raised to minus 13. So what's our option? 2 into 10 raised to minus 13 molar. Option 3 is the correct answer. Clear, dears? Got it? Okay, fine. We can go to the next question. This actually again in 2019. The same way, same kind of question. Okay, same way, same kind of question in 2019. Before that year also they asked it. What's the question? Here they given pH of a saturated solution of CaOH twice is 9. They are asking the solubility product KSP of CaOH twice. What's the solubility product? CaOH twice, that will be dissociate like what? Ca2 plus 2OH minus. To find out solubility, solubility product equal to concentration of Ca2 plus into concentration of OH minus all square. So we must have to know the concentration of Ca2 plus, concentration of OH minus at equilibrium. For that they given what? Saturated solution of pH value they given 9. What is pH? pH 9 equal to, meaning concentration of H plus equal to 10 raised to minus 9. Meaning pH equal to 9 means POH equal to 5 because total equal to how much? 14. So concentration of OH minus equal to how much? 10 raised to minus 5. So we got the idea. Concentration of OH minus is how much? 10 raised to minus 5. Then what's the concentration of Ca2 plus in saturated solution equilibrium? Just it's half. Because here if it is 1 is reacting, 2 will be forming, here 1 will be forming. So 10 raised to minus 5 by 2. So how I can write? Concentration of Ca2 plus is 10 raised to minus 5 by 2 into OH minus is 10 raised to minus 5 all square. So that is 10 raised to minus 10 into 10 raised to minus 5, 10 raised to minus 15, okay, into 1 by 2. That is 0.5 into 10 raised to minus 15. So option 1 will be coming. Clear, dears? That also related to KSP. That way also they can ask. Set? Okay. We can move to the next question. This is the question in 2019. What's the question? Which will make basic buffer? Which will make basic buffer? So basic buffer means what, dears? Basic buffer means it is a mixture of weak base should be there. Weak base should be there. That should be with a salt of strong acid. Salt of strong acid. That's the idea. That idea if you know means then we can easily calculate. We can easily find out. Weak base, salt of strong acid. What about NaOH? It's a strong base. So and CH3COH, weak acid. Not possible. Basic buffer not possible from there. What about this one? Acetic acid, that also not possible from there. What about the third one? That is the easy one. Here it is strong acid is there and base is there. Weak base is there. From there it is possible. It is weak base. From there it is possible. That's the answer actually. Option 3 is the answer. Still now you may have doubt how it is possible, sir. What's the idea? Idea is simple, dears. Idea is simple. So this one, see, we can consider in the case of this first one, we can consider in the case of their volume they given, molarity they given. Then we can find out the number of millimoles. What do you mean by number of millimoles? Volume into molarity. That's what's called number of millimoles. So if I am multiplying 50 into, first option I am taking 50 into 0.1 means 5. So 5 millimole NaOH. Okay, 5 millimole NaOH. As well as 25 into 0.1. 25 into 0.1 means 2.5 millimole what will be there? Acetic acid will be there. So same number of millimoles will react. So here from here 2.5 millimole of acetic acid, 2.5 millimole of NaOH will react. They will form 2 millimole of what? Salt they will produce. Then remaining will be this base will be more. So some salt we will get, then base will be there. But that is not basic buffer because this base is what? Strong. That's not possible. Let's directly go to the option number 3. What about option number 3? Option number 3, here 100 into 0.1. That's the number of millimoles. Volume into molarity. So 10 millimole of, listen to me very carefully, 10 millimole of HCl is there. Okay, dears? And here 200 into 0.1. 200 into 0.1 means 20 millimole of what is there? Base is there. Weak base is there. So we know that equal millimoles only will react. So here 10 millimole how to react? 10 millimole of base. 20 millimole required, 20 millimole is not there. So this is the limiting reagent. So 10 millimole of HCl will react with 10 millimole of base. So 10 millimole of HCl will react with 10 mole of NH4OH means they will form NH4Cl they will form. That's a salt. Plus what also will be remaining? 10 millimole of base will be remaining. NH4OH will be remaining. That is what is called buffer. Which buffer? Basic buffer. So our answer is what? Third one. Clear, dears? Okay. Next question. Next question. This is actually in question NEET 2018 question. Let's look about the question. What about the question here, dears? Here they are asking the solubility of BaSO4 in water is 2.42 into 10 raised to minus 3 gram per liter. Then the value of solubility product. So what's the solubility product? KSP equal to, that's the thing. In the case of BaSO4, that will be dissociate like Ba2 plus SO4 2 minus AB type salt. If it is solubility is S, this also S, this also S. So KSP is equal to S square. Our answer is in mole square per liter raised to minus 2. But here it is in gram per liter. How I can convert solubility? See, solubility in gram per liter they given, that's equal to 2.42 into 10 raised to minus 3. Then how I can convert into solubility in mole per liter? Solubility in mole per liter means solubility in gram per liter divided by molar mass of solute. Molar mass of solute. So that means 2.42 into 10 raised to minus 3 divided by your salt, which is your salt BaSO4. Its molar mass they given 233. That is the solubility that I have to apply here. So 2.42 into 10 raised to minus 3 divided by 233. Okay, 233 all square that I have to apply here. So that will be equal to, while I am solving this one, KSP equal to, I will get what? 1.08 into 10 raised to minus 10. 10 raised to minus 10. Option 1 will be the correct answer. So direct question, only the idea is that conversion we have to remember, then calculation. That's your part. That's your headache. I hope you will do it. Yes, the NEET students, they are actually very lazy to solve the mathematical questions and all. You have to practice. You have to do the calculation. No one will be there in your exam hall. You are your superheroes. Okay, will you do it? Yes, dears. Okay, you can. Okay. Next one. Next question. This is the question in 2018. Here also the logic, if you know, then you can easily solve it. This is the question. Following solutions were prepared by mixing different volumes of NaOH and HCl. Okay, then they are asking pH of which one of them will be equal to 1. Which case that's equal to 1. In the case of NaOH and HCl, their N factor is 1. So we have to think about what? Their number of millimoles. So the pH calculation and all, one video we already did that you can check it in the comment box. You can check it there. Okay, see here. Here the question is, following solutions were prepared by mixing, that idea, pH only we have to calculate. This is a strong acid, strong base I am going to mix. So that time I have to calculate what? Concentration of H plus mix equal to, Okay, concentration of H plus mix is equal to normal n factor is 1. So automatically normality and molarity are same. I will write it is molarity of acid into volume of acid minus molarity of base into volume of base divided by volume of acid plus volume of base. That will be the concentration of H plus mix. So that formula I am applying here. First case I am applying in option A, I am applying. That time here you see concentration of H plus, how much it is coming. So here 60 into its volume is 1 by 10. Okay, minus of 40 into 1 by 10. I mean molarity is 1 by 10. Okay, volume is 60. Divided by total volume 60 plus 40, that will be 100. So that is equal to 6 minus 4 divided by 100. That means 2 by 100. That means 2 into 10 raised to minus 2. That is H plus. Then pH cannot be 1. pH equal to 1 means concentration of H plus should be 10 raised to minus 1. That minimum idea we have. Correct? That minimum logic we have. This is 2 into 10 raised to minus 2 minus log if I am taking means 2 minus log 2 will come. 2 minus log 2 means 1 point something. We need 1 equal to 1. So that is not the option. What about the second one? B. 55 ml of m by 10. So second option if I am doing, see, you can see 55. 55 into 1 by 10. That means 5.5. 5.5 minus 45 into 1 by 10. That is 4.5. Divide by that also 55, 45, 100. That means 1 by 100. H plus is 1 by 100. So pH is 2, not 1. Okay. Then what about C? What about C? C is 75 into 1 by 5. 75 into 1 by 5 is 15. Minus 25 into 5. 25 into 5 is 5. Divided by total is 100. So that means 100 means 10 by 100. That's equal to 1 by 10. That's the concentration of H plus in the case of third. So concentration of H plus is 1 by 10. That is 10 raised to minus 1. So pH equal to 1. Option C is the correct answer. Clear, dears? So here is the next question in 2018 they asked. Okay, see. Here this is the question. Which one of the following condition will favor maximum formation of the product in the reaction? That's actually related to what? Which law? Le-Chatelier principle. They given one equation. What's the equation they given, dears? A2 plus B2 reversibly gives X2 gas. Okay. So this is gas. This is also gas. And they're telling like that the forward reaction. Enthalpy of forward reaction is minus X kilojoule. That means forward reaction is what? That is actually exothermic reaction. So which condition more product will be getting? So what's the condition for exothermic? Whenever you are decreasing temperature, the system will try to increase it. That is exothermic. So the idea is temperature should be less. Temperature should be less. That time the system will try to increase it. Exothermic reaction will favor. Temperature is high means system will try to decrease it by endothermic reaction. That's the idea. That's the logic. Whatever you are doing, the system will try to oppose it. That's what is Le-Chatelier principle. If you try to increase the temperature, system will try to decrease it. If you try to increase the pressure, system will try to decrease it. Whatever you are doing, the system will try to oppose it. That is what is called what? Le-Chatelier principle. That idea you know, basic idea you know, you are having. So the idea is simple. Your temperature is decreasing, the system will try to increase it. The system will try to what? Increase it by exothermic reaction. So we need exothermic reaction, then only we will get what? More product here. More X2 here. So the idea to get more product, more amount of X2, we have to reduce the temperature. So idea is low temperature, only two options. Next, pressure. Pressure depends on the number of gaseous molecule. More the number of gaseous molecule, more collision, more pressure. Lesser the number of gaseous molecule, less collision, less pressure. So what's the idea? Here you see, here how many gaseous molecules are there? One gaseous molecule is there. Here how many gaseous molecules are there? Two gaseous molecules are there. If I am increasing the pressure, system will try to decrease it by reducing the collision, forward reaction. So the idea is I have to increase the pressure. Increase the pressure. So high pressure. So option 1 is the correct answer. Only Le-Chatelier principle. That's it. Okay? Yeah, fine. We can move to the next question, dears. This is the next question. Question 2017. See, a 20-liter container at 400 Kelvin contains carbon dioxide gas. Carbon dioxide gas is there, okay? At a pressure 0.4 atm and an excess of SRO. Neglect the volume of solid SRO, okay? SRO, strontium oxide you are adding. The volume of the container is now decreases by moving the movable piston fitted in the container, okay? That will be moving. the maximum volume of the container when pressure of carbon dioxide attain its maximum value will be, then they given that equilibrium reaction they given. This is the equilibrium reaction SrCO3 solid. That is reversibly giving what? SRO. SRO solid plus CO2 gas. So now let's look about the equilibrium condition I can take. This is solid, this is solid. So equilibrium constant Kp equal to partial pressure of carbon dioxide, because of carbon dioxide only. This pressure is 0, this pressure is 0. This Kp value they already given. Kp value how much they given? 1.6. So partial pressure of carbon dioxide equal to 1.6 atm itself. That's equal to 1.6 itself. That means at equilibrium value, pressure we got 1.6. They are asking about that maximum value, that the maximum volume of the container at this pressure, what will be the volume? That's the question. So at the initially 20 liter and pressure is 0.4. So that is initial pressure. Initial volume I will take it is V1. Initial pressure is P2. This is the final pressure of carbon dioxide, 1.6 atm. That time, what will be the volume? Initial pressure, initial volume. Final pressure, final volume. Boyle's law we can apply. P1 V1 equal to P2 V2. Initial pressure is 0.4 into volume is how much? Volume is 20 equal to final pressure is how much? 1.6 into volume we have to calculate. What's the volume? So volume equal to 0.4 into 20 divided by 1.6. I can cancel this one I can cancel 4. 20 divided by 4 is 5. So what's the maximum volume? 5 liter is the maximum, the maximum volume of the container when pressure of carbon dioxide attain maximum value. That means that's actually 1.6 is the maximum value. That's the equilibrium value. That time volume will be how much? 5 liter. Option 4 is the correct answer. Okay, dears? Yes. We can move to the next question. This is the next question. This is also related to the property of equilibrium constant. What's the question? The equilibrium constants of the following reactions they given. N2 plus 3H2 reversibly gives 2NH3 K1. And equilibrium constant of N2 plus O2 that reversibly gives 2NO that given K2. And equilibrium constant of H2 plus R4 reversibly gives H2O K3. Then this reaction's equilibrium constant I have to calculate. For that first I need 2NH3. So I need NH3 containing equation. Is there an equation containing NH3? Yeah, this first equation. But NH3 is in right hand side. I need it in left hand side. So what should I do? I will reverse that one. So if I am reversing that one, that will be like 2NH3 reversibly gives, you can see 2NH3 reversibly gives N2 plus 3H2. Whenever we are reversing an equation, its equilibrium constant become reciprocal. So that become 1 by K1. Its equilibrium constant become 1 by K1. Okay, that's fine. Next, oxygen. In every reaction, oxygens are there. That I will consider later. Next, I need NO. NO I required. Is there an equation containing NO? Yes, this equation containing NO. And I need NO at your right hand side. 2 NO I required. So, same equation I will take. 2 N2 plus O2. Okay, reversibly gives 2 NO. Its equilibrium constant is how much? Its equilibrium constant is K2. That I will take as such. Next, I required what? 3H2O I required. Is there an equation containing H2O? Yes, this equation containing H2O. That equation, how many H2O? 1 H2O. So what should I do? I will multiply that equation with 3. So that equation become 3H2 plus 3 by 2 O2 reversibly gives 3H2O. Whenever you are multiplying with a number of equilibrium with a number, that time equilibrium constant means that number will be go to its power of the equilibrium constant. So that become K3 cube. That become K3 cube. Now you have to add all the equation. 2NH3 plus N2. N2 will get cancelled. Okay, H2, 3H2 will get cancelled. O2, 1 O2 plus 3 by 2 O2 means 5 by 2 O2. Reversibly gives 2NO plus 3H2O. So whenever you are adding equilibrium reactions, equilibrium constants, you have to multiply. So K2 into K3 cube divided by K1 will come. So K2 into K3 cube divided by K1, that will be the equilibrium constant. This is the answer, K2 into K3 cube by K1. Option 3 is the correct answer. Clear, dears? Only the property of what? Equilibrium constant. Don't be confused with enthalpy. In the case of enthalpy, whenever you are reversing, the sign will change. When you are multiplying, you have to multiply with equilibrium constant. But here it is not like that. Whenever you are multiplying with a number, that number will be goes to equilibrium constant's power. And whenever you are reversing, equilibrium constant become reciprocal. Okay, don't forget. Fine, dears. We can move to the next question. This is the next question. This is in question asked in 2017. Concentration of the Ag plus ions in a saturated solution of Ag2C2O4 is, okay, 2.2 into 10 raised to minus 4 mole liter inverse. They are asking solubility product of Ag2C2O4. So Ag2C2O4 I am taking silver acetate. This one will dissociate like 2Ag plus C2O4 2 minus. And the solubility, the concentration of Ag plus ions in saturated means at equilibrium. Equilibrium, Ag plus concentration they given 2.2 into 10 raised to minus 4. Okay, if it is 2, it will be 1, no doubt. So, if it is 2.2 into 10 raised to minus 4, then 2.2 into 10 raised to minus 4 by 2, that means 1.1 into 10 raised to minus 4. That's the idea. They are asking about the solubility product. Solubility Ksp equal to concentration of Ag plus all square into concentration of C2O4 2 minus at equilibrium. So, this value we know 2.2 into 10 raised to minus 4 all square into 1.1 into 10 raised to minus 4. This one I will write it is 22 into 10 raised to minus 5 all square into 1.1 into 10 raised to minus 4. 22 square. See, 22 into 22. 20 square we know we are doing like this. Okay, 22 into 2 to 4, 2 to 4, 4, 4. So 484 will come. 484 into 1.1. 484 into 1.1. 484, 484. Okay, so 4, 2, this one will be 3, this one will be 5. Then again that 1.1. So 5.32 into, not 5.32, I'm sorry, 532.4 into, here 10 raised to minus 10, 10 raised to minus 4. So total 10 raised to minus 14. So but answers are 5.2 like that. So 2 more point I will take to left hand side. So that will be become 5.32 into 10 raised to minus 12. Is there any option? Yes, option 3 is the correct answer. So that's all about the question, dears. We discussed from 2017 to 2024. Last year, up to last year we discussed. I hope all the questions are clear. You don't have if you have any doubts in any question in the video, you can comment it in the comment box. Okay, we will be there to help you. I will come with more videos of the PYQs of the different chapters. Stay tuned, dears. Thank you so much. Tata, bye bye.